When we learned how to multiply polynomials using FOIL and the special methods, we essentially learned how to expand polynomials. But sometimes it's not easy to use an expanded polynomial. There will be times when we need to do some operation on a polynomial and find that we can't because the degree is too high. This is why we had to learn about the GCF. It allows us to take a polynomial of a high degree and decrease it. This process is called factoring. Factoring polynomials can be tricky. You have to be quite familiar with elementary products to have an easy time. Otherwise, you end up relying on a lot of guesswork, and that's not very efficient. In this first lesson, we'll be working with factoring trinomials in the form of x²+bx+c, where b and c are coefficients and r. I have here an example of FOIL being used. The method produced 3 terms, but more importantly, it produced 3 unique coefficients: a square of the first coefficient, a sum of the second terms, 2 plus 3, and a product of the second terms, 2 times 3. Take note that the 2 constant terms of our binomials are what's used to produce our coefficients in our trinomial. Let's begin to work backwards now. Start with the trinomial, x²+5x+6. Our goal is to end up with a product of 2 binomials. So let's write that out. X plus some number times x plus some number. We know the first terms of each binomial are going to be x's because x squared can only be factored as x times x. But now we need to find 2 numbers. Look at the coefficients that FOIL initially produced from the binomial, a sum and a product of the constants. This product and sum were produced from 2 numbers. So we need to find those 2 numbers. In other words, we need to find 2 numbers that when they're multiplied together, we get c, and when they're added, we get b. It's easier to start with c, the product, so let's start there. We have c equals 6. So list the factors of 6. 1 times 6, 2 times 3. One of these products is our answer, and we are going to find it by figuring out which one of these sums up to positive 5. 1 plus 6 equals 7. 2 plus 3 equals 5. We can see that our second option, 2 and 3, adds up to 5. So let's plug those numbers into our binomial. X plus 2 times x plus 3. And look at that. We have our original product. Let's work out a few examples. Number 1, x² + 9x + 20. We need 2 numbers that multiply to give 20, but add together to give 9. Let's start with the constant term c. Its factors are 1 and 20, 2 and 10, 4 and 5. Next, we find which set of these adds up to the b coefficient. 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9. The third set fills those criteria. So a binomial product is x plus 4 times x plus 5. If you're not sure if your choice is correct, you can always use the FOIL method and check that your answer equals the original trinomial, x² plus 5x plus 4x plus 20, which simplifies to x² plus 9x plus 20. Our check certifies that we have the correct binomial product. Number 2, x² plus 2x minus 8. Now we have a trinomial with a negative number. This means c equals -8. So we need 2 numbers whose product equals -8 but adds up to +2. Now we know that a positive number multiplied with a negative number gives a negative product. We also know that if a small negative number is summed with a larger positive number, the sum will be positive. So with our two numbers, we know the smaller one will be negative. Let's fill out our binomial product. We know we're going to have x plus some number times x minus some number. Let's now list our factors of 8. We have 1 and 8, 2 and 4. Remember, we need our smaller number to be negative. Our sums are 8 minus 1 is 7, 4 minus 2 is 2. This means that the second set is our correct choice. X plus 4 times x minus 2. Just to check if we did in fact pick the right choice, FOIL gives us x squared minus 2x plus 4x minus 8, which simplifies to x squared plus 2x minus 8. We have the correct answer. Number 3, x squared minus 5x minus 6. We now have two negative coefficients. Just follow the same procedure. The factors of c are 1, 6, and 2, 3. Let's think about the logic now. To get a negative product, only one factor can be negative. We also have a negative sum, so that means this time the larger number is going to be negative. The sums of the two sets are 1 minus 6 equals negative 5, 2 minus 3 equals negative 1. The first set gives the correct answer. Therefore, our product is x plus 1 times x minus 6. Let's check our answer. FOIL gives us x squared minus 6x plus x minus 6, which simplifies to x squared minus 5x minus 6. We have the correct answer. Number 4, x to the 4th power plus 11x squared plus 18. You might be thinking that this is impossible, but it's actually quite simple. We're looking for the GCF of each term. Remember a few lessons ago, I was making an effort to point out that the first two terms of the trinomial was the GCF of the first terms of the binomial, and the last two terms of the trinomial was the GCF of the second terms of the binomials. With that said, we can see that our GCF of the first two terms are x squared. Setting up our binomial product, we have x squared plus some number times x squared plus some number. Our factors of 18 are 1 and 18, 2 and 9, 3 and 6. The sums of these sets are 19, 11, and 9. The only set of numbers that sums up to 11 is the second set. So our binomial product is x plus 2 times x plus 9. Checking our answer with FOIL gives us x squared plus 9x plus 2x plus 18, which simplifies to x squared plus 11x plus 18. This was only part 1 in our series of factoring polynomials. There are a lot of subjects that involve factoring, and I want to take my time with each one, giving each important subject its own video. This lesson specifically dealt with trinomials of the form of ax squared plus bx plus c with a equal 1. In the next lesson, we'll learn to factor trinomials that has a not equal to 1.